Earlier this year, I did a video showing how close the moon is on a flat Earth by using a right triangle formula. And after I posted the video, I was confronted by people saying that my calculations were wrong, because if you need to take in the you need to consider the curve of the Earth. If you take in the curvature of the Earth and then you do the math, you'll see that the moon is exactly where it's supposed to be. Now, that's nonsense. I'll go ahead and say that right up front. That's nonsense. But why argue that point when there's a much better point to be made concerning the sun? As you know, the moon is 235,000 miles away, roundabout, somewhere in that neighborhood, depending on the orbit and everything. That's what they tell us. That's their numbers. But the sun is 93 million miles away. Okay, so correct for all the curvature that you want to. Okay, correct all day long. This is going to settle the score. Now, there's one more thing I want to mention before I get into this video, and that is what I'm actually measuring. I took a lot of grief for saying that I had pinpointed the exact location of the moon. You have to in the prior video, and I'm going to do the same thing with the sun here. But you have to understand, I'm not pinpointing the sun itself. I'm only able to pinpoint the apparent sun. So these numbers are not. You can't fly out there. Here in a minute I'm going to present a number and how far the sun is. You can't jump in a plane and fly that distance and run into the sun. The sun is it's a light, and there's a dome overhead. So what we're really seeing, depending on our position on the Earth, we're seeing what's known as an apparent sun. We're seeing a reflection. So we're never able to see the real source of the light. So it's like almost like trying to chase down a rainbow. Depending on where you're standing, that rainbow is going to move based on other conditions, the water, vapor in the air, and that kind of stuff. Wherever you move, that's going to change position. The sun, the moon, the stars all work very similarly in that regard. Okay, so getting into the experiment now, we'll have an overview of what we're looking at. I've pulled it up here on a globe model, so all you globe heads can kind of get an idea of what the dimensions of my experiment are. It's 5,460 miles distance between Smith Island in the north and the equator. Those are the two locations I'll be using, just like I did the same exact 2 points that I did in the moon video. Now, on a flat Earth, you'll visualize something like this. The same distance, the same two locations, just modeled differently. Okay, here is a screenshot from Stellarium. This particular day, the sun was in zenith. It's 9:16 at 1:49 and 11 seconds UTC time. At that particular day and time, the sun was in the zenith at the equator. Now, this is our first marker, our 90-degree angle that will form our right triangle. Now, here's another screenshot from Stellarium from our secondary location on Smith Island in northern Russia. And as you can see, the sun is right about the 10-degree mark. Now, I'm going to zoom in on it because I want to get this thing exactly right. I don't want to cheat the globe heads any at all. So we want to get the precise angle. Now, if you zoom in, now, and I hope you see what I'm doing here. This is the azimuthal grid that I'm zooming in on here, and as I zoom in closer, it gives me more detail on the exact angle. And we see here that it's not quite 12 degrees, but I'm giving you 12 degrees anyway because it's not gonna matter. And again, you notice the time and date exactly the same as it was in the first screenshot. Okay, now that we have our data, all that's left to do is visit our friends at Cleve Books again and enter the data into their right angle triangle calculator. Now, We enter in the 5460 as the distance as the base of the triangle, and we enter in 12 as the angle at point A shown here. We put in 12 for 12 degrees. Even though it wasn't quite 12 degrees, it doesn't matter. And all that's left to do is click the button. And what do we come up with? Well, we have our answer, don't we? 1,160 miles straight up from the equator is the apparent sun. The sun is not millions of miles away, folks. The sun is very close on a flat earth. So for all you globe heads out there, you'll notice that I didn't bother to reconstruct your curvature argument, correcting for the curvature, because first off, there is no curvature. But with the sun so much farther distant than the moon, that should not matter. Okay, you're talking about 93 million miles. A little bitty curve isn't going to make a difference. So you show me how it is. You can correct for the moon and make it look reasonable. Like, oh, look, you didn't correct for the curve and the moon, therefore you're wrong. But I want to see you do it for the sun. Well, that's all I've got today, folks. Thanks for watching.